A circular swimming pool has a diameter of 24 feet. The sides are 5 feet high and the depth of the water is 4 feet. How much work is required to pump all the water out over the side? Use the fact that water weighs 62.5 pound per feet cube. So here's the circular pool. I drew it as of a cylinder being a circular on the base, and then 5 feet height and 4 feet of water. I put the 0 from the top of the pool because every time I want to measure any distance that any slab of water has traveled, I need to find the distance from the top, and it's easier to figure it out when the origin is on top, then the distance will be x. Again, that's not the only way of doing it. I bring one tiny slab of water out, letting the height to be delta x, or you can just say dx. And volume of that small piece, I can name that delta v, just like the volume of that tiny piece is pi r squared times height, which is delta x. Just keep in mind that weight times volume, so weight times volume is equal to the force. So basically pound itself is another, when you are in the pound and feet system of units, then pound itself is the force. So weight times volume will give you the force automatically. So weight is 62.5 pound per feet cube. I'm going to also write the unit so you see that they cancel, times pi r squared delta x feet cube, and this one is also the unit is feet cube, cancel, so that's why pound remains, and that's again another when you're in the system of feet and pound, that's where the force unit is, just pound. So multiplying 62.5 by pi by r squared, you'll get 9,000 pi delta x. To find the work here for that one tiny slab, it's gonna be 9,000, just work to pull that up, or any slab with a distance of x from the top, that would be 9,000 pi, and then there's the x distance because we said it's w is force times distance, so distance is x, and then you had the 9,000 pi delta x. So to find the work for all of them, so it's going to be 9,000 because you have many of those slabs. I'm going to make it a tiny, instead of delta x, I write it as dx. And in this case, it's going to, so since the first slab you take, it's going to be 1 meter from the origin. So I start from 1 meter. And then the last slab that I take, it's going to be down here. So it's going to be 5 feet from the top. So that's the setup. Now you calculate it, 9,000 pi x squared over 2, going from 1 to 5, just taking the integral. 2 and 9,000 cancels to 4,500 pi x squared. You make the appropriate substitution, and your final answer should be 108,000 pi feet pound. Okay, next example. Okay, the following tank is full of water. Find the work to pump the water out of the spout. Water density is 1000 kilogram per meter cube. So here's the shape. Let's take the origin again, and now this time let's take the origin from the top of the shape here, not from the top of the spout up there. Or you could have done it, but I will just take it from the top of the shape. So going down, 0. I know the height here is 3 meters. And you want to pump all the water out. Think about a slab of water out. If you take a slab of water, it's going to be a rectangle. So you're going to have a rectangle with the height of delta x or dx. I'm going to put it as delta x. And then it's 8 meters on the length, so it's easy to identify this one. The height is delta x, that's easy, but then the width is coming from this triangular shape right here. So if it comes from this triangular shape here, I'm going to draw that triangular shape out here. I know that this height of the slab that I'm taking out, it's coming to be across from this triangular shape. That's going to be what I identify later here. Whatever I get as of this triangular length, then I'm going to put it here as a width of my triangle. So I'm going to use the proportion of similar triangles. So the half of this triangle, let's say, half of it right here, is proportionate to this small triangle at the bottom here. Okay, you know the top part of this triangle is 1.5 here because the entire thing was 3, but I just need half of it is 1.5. You know the entire height is 3. So that's the entire height. But the height from the bottom, if you imagine that every step you are x away from origin, then this measure, it's gonna be 3 minus x. So if this measure from the top is x, then the remaining for the side of triangle is 3 minus x. So and I'm looking for this distance here. I'm gonna double it later because I need the entire cross. So that would be 1.5. The proportion of 1.5 to d is the same thing as, so 1.5 to d is the same thing as 3 for the bigger triangle to 3 minus x on the smaller one. So from here, we're going to isolate d. You can do that by cross multiplying. So 3d is equal to 1.5 times 3 minus x. Then you divide everything by 3, and that's d. But our goal is to find double of the d because that's going to be across from this triangle. So 2d is 2 times 1.5 times 3 minus x over 3. 2 times 1.5 is 3. So 3 times 3 minus x over 3. Basically, 2d is just 3 minus x. So what you have here is 3 minus x. Okay. So now we're going to find the force. Force will be density times volume. Volume is length times width times height. times G, and then you're going to multiply force by distance, that is 2 plus x. So instead of 1008 times G, I write 8000 G, and I bring 8000 G out. So then you would have 8000 G times 3 minus x. That part is for the force, along with the delta x, that is now turning to dx. 2 plus x is the distance, so force times d is the work. It starts from 0 to 3. So if you think of the x starts from origin and goes all the way to the bottom of the shape, that is 3. So that's why you go from 0 to 3. And you are taking care of the spout height basically by adding 2 here. So to calculate the final answer, you pull 8000 G out, and then you FOIL 3 minus x, 2 plus x, to 6 plus x minus x squared, and then dx. Take your integral of that. Do the substitution of 3 and 0. So your answer is 1058400, and unit is joule. So it's 1,058,400 joules. And if you're writing the answer or rounding, you can say it's about 1 point scientific notation, 1.06 times 10 to power 1, 2, 3, 4, 5, 6 to power 6 joules. That's the answer. So that's the end of the examples of this section.